My dear students, today we'll discuss few more concepts related to data link layer. That is, first module is related to that is about introduction to computer communication. We have discussed so many concepts related to computer communication network. Today we'll discuss some concepts related to second module of the computer communication network. In that we'll discuss about framing. What do you mean by framing? Framing means that is dividing the complete memory into the parts is known as framing. That is dividing the complete part sorry dividing the complete memory into the parts is known as framing. Suppose 1,000 pages is there. Thousand pages of soft copy is there. 1,000 pages. Suppose this is book is which it is of 1,000 pages. It is of 307. Like so many pages are there in this book. Nearly it is of 1,000 pages. Then suppose we want to transmit this book soft copy of this book then we can't transmit all the pages one by one continuously, because in the system only two systems are not there in the network. There may be so many systems in the network at that time. Suppose system which through which I want to transmit at that time, what happens? Suppose I want to transmit the information that is from source 1 to from system 1 to system 4. At that time, not only the system 1 is there in the network, system 4 is not only not is there in the network, other systems also there, 2 3, like in a internet. If you go to internet shop at that time, there may be 10 systems, 20 systems may be there. At that time, suppose I want to transmit the information, a soft copy of this book from 1 to 4. At that time it is of how many pages? 1,000 pages. At that time this may take for example I'm telling 5 minutes or 4 minutes, like this. At that time, when it is using this path for transmit of data from system 1 to system 4, suppose it is taking so many time. At the same time, only in the network only two systems are not there. In the network there may be 10 systems, 20 systems are there, and all are connected by, that is LAN, that is local area network. At that time, suppose system 2 also want to transmit the information to system 3. At that time, it has to also use the same path, same cable to transmit the information. At that time, what happens? One is also transmit the information, two is also transmit the information through the same path, same cable, same wire. At that time, what happens? Mixing of the information, mixing of the signals. At that time, what happens? At the receiver, when 4 receives, it will receive the information which is transmitted by system 1 and system 2 also. At the 4 and also in the 3 also, not only receives the information transmitted by the system 2, it also receives the information, the soft copy of this book or something, which is transmitted by system 1 also. Therefore, at the receiver, it will receive the combination of the information which is transmitted by system 1 and system 2. At that time, here it can't understand, that is what is the information. Suppose here, this is 1,000 pages, so soft copy of this book is there. Suppose this system is transmitting the soft copy of the system, soft copy of this computer communication network subject these pages from system 1 to system 4. Suppose this second system is transmitting the soft copy of same 1,000 pages or 500 pages, whatever subject. For field theory if you take, for example, signal system you take, it is also 500 600 pages. Suppose it is also transmitting to this system 3. At that time what happens, when same time both the systems are using same path, or they have to use the same path, same, because only one path is there to transmit the information from one system to other system. When both are transmitting, at that time this will receive to want to transmit the information from system 2 to 3. For example, signal system, it want to transmit the soft copy of the book signal system, it will start. One want to transmit CCN soft copy from 1 to 4. When both are transmitted simultaneously, means system 3 will receive the combination of some pages of signal system and CCN. Both are combined. Here in system 4 also, not only it will receive only the soft copy of CCN, it also receives the combination of signal system also. Therefore, the whatever system receiver who is there in the system 3 and 4 will not receive the complete information or understand the information correctly. Here you see the book, everything, all the pages are related to CCN only. It is only all the concepts are related. 1,000 pages are there, and it is only related to the computer communication network. Suppose here it comes soft copy and half of pages of CCN, half pages of signal system. Then reader can't understand the information. Therefore, it is very important. It is system 4 should receive only purely the soft copy of the subject CCN. These three should receive only the soft copy of book, that is signal system, which is transmitted by system 2. Then only the reader who is there in the system can understand the concepts, the information related to signal system. This 4 also can understand the subject related to CCN. Therefore, we have to do framing. Why framing means, instead of 1,000 pages, only here we'll make only the pages of 100. Like we'll divide the complete into 100 pages, 100 pages, so that small packet in the form of packets it will transmit. When it is received afterwards, if it is also transmitting, when there is no collision and only some small time is taken to send the packets from this through this cable or path, at that time there is no collision of the packets. Therefore, we have to do framing so that we can avoid collision. And this part is not only meant for only to transmit that should be utilized by only by one system. It should be utilized by all the systems which are connected in LAN, that is local area network. Therefore, we will do framing so that we can have the flow control, error control, access control in the network. Therefore, this is called as framing. In framing also, we are having that is fixed size framing and variables. Two types of framing: fixed size framing and variable size. In fixed size framing, that is the sender and receiver, that is transmitter and receiver, knows that if it is transmitting, making a packet of 100 pages, and this receiver should also know how much it is transmitting. In fixed size framing, it knows that it will transmit the transmitter or sender will send only 100 pages from system 1 to system 4. After 100 pages, it come to know that Okay, one frame it is received. Afterwards, what happens? It will send one more 100 pages, and it will receive those 100 pages, like in the form of packets. How it is made? How it will? It is a structure of a frame. A frame in a character-oriented protocol. This is up to this. This is what. This is the data. Suppose 100 pages, and not only it will transmit the data, it will add in each packet, in each frame, it will add header and trailer and also flags. This header and trailer contains the source address and destination address. Here in this, which one is the source address? 41 is the source address. Here, which is the destination? Sorry, one is the source address. Here, four system is the destination address. Therefore, when it is transmitting the data, the packet or frame not only contains the data, it contains the source address and also the destination address. When it is transmitting this through this part, this data is not delivered to this system too. Why? Because the destination system address is not matching. Here this is 4, but it is 2. Therefore, this data, when it is propagating, this data is not transmitted to. This will be taken care by data link layer. This is called as physical addressing. Therefore, why the information transmitted by system 1, why it will go to 4 only, why not to 2 and 3? This is because this is the beauty of making framing. This is how the data link layer will take care of transmission of data from particular system to particular system. Therefore, it is called as protocol. Often we come across these all are what is data link layer, network layer, transport layer, all are protocols means what? A set of rules which governs the communication between the two systems. Set of rule, it will tell that this packet destination is mentioned is 4, but when you come here, it will not, even though path is there, the connection is there, that this data is not transmitted to system 2. When same, it will come to here also. It can go, but data, this can go here, but it will not deliver this data to system 3. Why? Because destination address is 4. Therefore, whichever transmitted by 1, it is transmitted to system 4 only. Therefore, this is how the data link layer will take care of transmission of data from particular system to that particular system only. Therefore, this is how this data may be. What is the here? Header contains the source and destination. To which system this data? Suppose example. It think that it is of 100 soft copy of 100 pages of this book. To that 100 pages, it will add header contains source address, destination address, title also contains some information, and these flags are added whenever this system 4 encounters the flag. This is the starting of the when it comes here. At that time, that the receiver 4 will think that data is coming here. This all it will treat as a data. When once again it will receive this flag, and at that time the system will come to know, okay, frame packet or some data packet is over. When receives such flag means nothing. Here also flag means it's some character means for example flag or some character. It may flag means some character or some pattern. For example, this is in bits. This is also a flag. Whenever such pattern occurs, then it will think this is start of the frame and end of the frame. In fixed size, it is need not to mention the that is start of the flag and end of the flag, but in variable size framing. In variable size framing, we have to mention the flag. What type of flag should be? What is the pattern of the flag? Why? Because here in variable size framing, this data transmission not fixed. Variable size framing. Why? Because in variable means sometimes the transmitter one not only transmit the 100 pages, it will not transmit only the 100 pages in variable size. Sometimes it will transmit 100 pages, sometimes it may transmit 150 pages, sometimes it may make a frame of 200 pages. Like it will make the frames of variable size framing 100 pages, 150 pages. At that time where it is very important to add flags. Therefore, whenever it encounters the flag, whenever it come to know flag, and this system will think that it will understand that okay, whatever next is coming is the data. Whenever such pattern or some flag will receive, it will think that it is over of the data is over. What that packet frame, whatever size, the whatever data is transmitted, it is over. Like this some because we are not only transmitting only 100 pages, 100 like this, we are transmitting 1000 pages, 2000 pages. Therefore it has to receive one by one, and at the same time it will not only receive that one, and also in turn it will transmit the acknowledgement to system 1. Why? Because how system 1 will come to know that is it has received all the packets successfully, because after receiving the acknowledgement only the system will come to know that system 1 will come to know that it has received all the packets. First it will transmit 100 pages, when it is received it send back the what acknowledgement, that is some small message, some small message to this system, so that it will come to know okay, whatever data you transmitted I have received, and the small packet it will transmit, that is called as acknowledgement. When it receives the acknowledgement, then only the system 1 sends the another 100 pages. This is how it will come to know the transmission of the data, how it will transmit, and when how all this 1000 pages soft copies is transmitted from system 1 to system 4. For example, suppose some I'm having so many some I want to suppose I want to send some my mask card xerox, my xerox copies of my mask card to VTU Belgaum. When I want to transmit my some 10 or 20 pages of xerox copies of my mask cards to VTU, then what I will do, I will make the xerox of my mask cards, and I will place in an envelope, and I will write to the address of the VTU, Vishweshwar Technological University, everything address, wherever the address, street, everything I mentioned. Belgavi I will mention. What is the pin code of the Belgaum I will mention, and also I will mention the state Karnataka. Like everything I have to mention. Then only it will receive to the V2 Belgavi. When it receives there, then how I am confirm? How I will come to know that my whatever document I have transferred to VTU, or I have sent to VTU, how I will come to know it all this is received to the VTU. Therefore, what in previous days what we used to do, we'll send a small piece of letter, some acknowledgement, like some small acknowledgement letter will send with that envelope. In that small letter, you know I don't you know or don't I don't know, because small piece will attach to that envelope. In that small letter, what will do, only there will write from who is sending that one, that letter, that envelope, to who I am sending, because my I will write from Dinesh Gosul, that is house number so and so, call this is like Vithal Nagar, Gulbarga, pin code will be 58102, and also I will mention state Karnataka, what is the street numbers, and everything I will mention, so that when they receive the envelope in V2 Belgavi, what they will do, they receive the envelope and they in turn send back that small piece of acknowledgement, that is acknowledgement to my to me. After some days I will get back that acknowledgement. When I get back the acknowledgement, what I will come to know, whatever the xerox copies of my marks card, whatever I sent to VTU, it has received successfully by the VTU. This concept of acknowledgement is very, very important, because the confirmation we require, whatever here in system also, system also, whenever it receives the acknowledgement, then only it will transmit another 100 pages, and unless and until it will not receive the acknowledgement, it will not send another 100 pages. Concept of acknowledgement is very important in computer communication network, because how it will come to know, whatever 100 pages it is transmitted, it is received by the system 4, unless and until system 4 sends the acknowledgement to 1, then only this system it will come to know that whatever it is transmitted, it is received successfully. This is how communication happens between the two systems. Therefore, here concept of framing comes, so that that is the path should be utilized by all the user system, the users who are using the systems which are connected in LAN, and also, and it can overcome the problem of flow control, error control, access control. That is about framing. In framing, we're having, that is some problem occur in framing. For example, flags are there, some flag is there at that time. Sometimes the flag is also the part of the data. This flag is maybe the part of this. You see here, this dot flag escape. This flag also may be the part of the data. At that time, when it comes from upper layer, the data link layer will, what it will do, it will add header, flag, and this will be the data. This is the data which should be transmitted, which is coming from network layer to data link layer. At that time, flag is the part of the data. At that time, when flag is part of the data, when system this 4 receives here, when it receives, it will think that before that it is the data link layer added flag here, header here. Suppose after this it receives flag, means it think that okay, packet is over, that data is over, but actually data is not, still so many data is there here. But whenever it encounters flag, this system 4 thinks that, oh, packet is over, the frame is over. But actually here the frame is over, no, this flag is also a part of the data. This is here, this flag is not the start of the frame or end of the frame. This is the part of the frame part. This data is this is the part of the frame. It is also some data, not the starting delimiter or end delimiter. Therefore, to avoid confusion, what data link layer will do, before sending this, it will add some character before the flag. That is escape character. Escape character it will add before sending to receiver, so that it should not misunderstand that this is not the end of the frame. This is also part of the frame. This is not a end of the frame. It is some data which is there in the frame. To avoid confusion, it will be, so that the receiver should not misunderstand. Therefore, it will add some escape character before the flag. And here also, but this escape character may be also part of the data, part of the frame. Whenever it encounters, so it will think that when it received here, at that time what will do, when the receiver side, whenever escape character comes, it will remove and it will consider next data as a data. This it will consider data as, but this escape may be part of that. Here it is also part of the frame, it is also a data. But when whenever escape comes, it receives means this is not the, it is a part of the data, it is part of the frame, it is also data. When it removes means some data is lost. Therefore, to avoid confusion, whenever escape is there, then therefore what it will do, it will add one more escape, so that next whatever next is there, whenever escape comes, next data, it should consider next data as a part of the frame, not the end of the frame or end of the frame or some. Therefore it is, whenever escape is also data, therefore before this escape it will add escape here to avoid confusion. Therefore here in frame, this header frame, this is the size of the frame, added flag, header, this is the data. Here flag is there, avoid confusion, it is added escape. Here escape is also data, here avoid confusion, it is added one escape here. This is the complete frame which is transmitted from system 1 to system 4. When system 4 comes here, frame received at the system 4. When it receives, and it will send to the upper layer. Before sending, what it will do, it is unstuff. This is a process called as stuffing and unstuffing, byte stuffing and unstuffing. Important question. Definitely such questions will be asked in exam. Explain with a diagram what is framing. Also explain byte stuffing and unstuffing with a neat diagram. At that time you have to draw this diagram and explain all the concepts. Therefore, when this frame comes to the receiver, what it will do, it will send it to the upper layer. Before that, it will remove wherever escape comes, and it will consider the next part as a data, but not a end of the flag, end of the frame or end of. Therefore, whenever escape here, 2 bytes are added, extra bytes. When it comes to receiver, this escape is received, and this is, it will consider as a data but not end of the data, end of the frame. Therefore, actually whenever flag comes, it will think that start of frame, end of the frame. But here in between flag is there, this is not the end of the frame, it is a part of the frame. This is a data, not a end delimiter or starting delimiter. Therefore avoid confusion. Here once again in the receiver, when it is transmitted to the upper layers, it will remove the escape characters, and this is escape is received, this escape is received, and this flag is as it is, this escape as it is. Therefore whatever data which is transmitted, same data is received at the upper layer. This after unstuffed, what is the data to upper layer, flag, some data. Here data they are not mentioned. Therefore in between we are having flag escape. Here also flag escape. Like whatever it is transmitted from system 1, same data is received at the system 4. Therefore concept of stuffing is important. Why? If it is not done stuffing, what happens? If flag here it comes, it think that it is end of the frame, but actually here, is it end of the frame? Still so many data is there, so many datas are here in the frame. Here this is not the end of the frame, here it is end of the frame. To avoid confusion, we have to do that is stuffing and unstuffing. Very important. Such questions will be asked in exam. Similarly, we are having bit stuffing and unstuffing. Bit stuffing. Such questions will be asked in exam. Very important. Similarly, you read what do you mean by bit stuffing and unstuffing. Very important. Here also, to avoid confusion and receive the original data which is transmitted by system 1 to system 4, from the transmitter to receiver, how we have to do the stuffing and unstuffing. This is bit stuffing and unstuffing. Okay, very important. Read the book to understand the concept of bit stuffing and unstuffing. Very important. Such questions will be asked in the exam. Okay. Okay. Thank you.